This is the front end of the application. To make easy the implementation, we used React.js as framework. Before do anything, we have to sign in. Okay, as you can see, we can visualize the tree using our own DNA sequences or samples given by application. The second option is still in development. So I'll visualize the tree using my own DNA sequence. As you can see here, we can upload the DNA sequence files by drag and drop or click and select. Now we have to upload each file one by one. Now upload is finished. Now we should put the title for the visualization. And we should choose the method for distance matrix. The KEMA method is still in development, so I choose LSA. Now matrix is generating. I can see my DNA sequence files in here, and from here I can see my past visualizations. This is the current visualization. It is still in progress. This will take few minutes. This is the generated distance matrix. I can download this matrix as a CSV file from here. Then I can visualize the phylogenetic tree from here. You can see now tree for the corresponding DNA sequences. There is a toolbox for customizing this tree. I can set this tree as vertical, and we can change the length of the links and gap of the links. I can also change the link type. I can also change the font size. Coloring is also possible. I can change the thickness of link from here, and I can also color the links. I can download the customized visualization from here and print the visualization from here. In past visualizations, now you can see our tree visualization and matrix visualization. At any time, we can open these visualizations.
I'm going to talk about the backend of our system. This is the deployment diagram of our system. Our backend is written using Django REST framework. I'll take two use cases and illustrate how the system works. The first one is user wants to log into the system. The request is username and password. The Django web app will get the request and it query from the database and check if the credentials are correct. If the credentials are correct, it sends back a response with the full name and a token. The second one is user wants to generate the distance matrix using LSH. The request is a title and the name of the files. First, the Django web app will get the request and check whether the request is valid. If it is valid, it creates a process object and it stores into the database. Then the process ID is passed into the RabbitMQ broker and send the response back to the client. In this system, the RabbitMQ broker acts as a queue. Celery worker consumes those messages in this queue and store the results in the PostgreSQL database. Now we look onto some code in our system. This is the method to generate the distance matrix using LSH. This method is consist of 6 subtasks. Create a directory to process the DNA files, download the DNA files from S3 bucket, generate the distance matrix, store matrix results in the results model, update the process, delete the process directory. Likewise, we commented the everything that is necessary, and we use best coding practices, and we use GitHub as the source control. It is natural for any software project to have problems. Let's look at major issues we faced and what are the solutions for them. When doing this project as a Scrum team, we consistently have to switch between development and production environments. This is difficult because then we have to do configuration for the environment repeatedly. The solution is Docker. It can isolate software and divide it into containers, making it easy to develop the software without worrying much about the environment. The environment configuration is fairly easy with Docker, and it is a trusted service around the globe. One of the many problems faced in software industry is the scarcity of resources. Phylogenetic tree construction is a complex process with matrix generation and tree construction, which requires decent amount of CPU power, memory, etc. With Heroku, it is not possible to achieve the optimum amount, and when multiple users using the software, the resources won't be enough. Therefore, RabbitMQ, an easy-to-use message queue, and Celery, an asynchronous task queue based on distributed message passing, is used. As seen on the diagram, user requests are passing through RabbitMQ broker and Celery worker before connecting to AWS Cloud S3 bucket. This can maintain a queue and manage resources to provide the services to all the users conveniently. Though the performance is not greatly enhanced, this is useful to manage multi-users simultaneously without crashing the system. Finally, communication. It is not easy to communicate with the team, especially in these times. However, it is necessary to maintain proper communication between team members to develop the software successfully. It is also important for the agile development. Jira is the best solution for this problem. It is an interactive web application designed to manage the workflow of an agile team. As you can see, it has easy to use user interfaces. It helps us to track on the current to do and finish tasks, and also it shows how we're doing with the time schedule. The application is suitable to assign new tasks, raise issues about current tasks, and to mark finished tasks. It has the capability to create progress reports and distribute remaining work. With this, managing workflow becomes simple. Other than that, we had to modify a React library for our preferences, enabling us to customize phylogenetic tree diagram generated in our application. These are the main issues occurred and solutions for them. As we progress through, we may have to face new problems and find new solutions.
Software testing is a key component of software product development because it improves consistency and performance. We done unit testing for components of front end by using these tools. Enzyme is a JavaScript testing utility for React that makes it easier to test our React components output. Jasmine is helpful for both front end and back end tests. And then we done unit testing for functions in backend by using the Django test suite. Then we done component testing for views in front end by using Jest framework and backend component testing by using PyCrunch. Finally, we hope to do end-to-end testing to Vault system. We hope to use Cypress.io for front end and Selenium for backend to end-to-end testing. We decided to divide two teams for front-end testing and back-end testing. Front-end developers done back-end tests and back-end developers done front-end tests.
If we consider the progress of our project, as you can see, we plan for mid-evaluation to do user management functionalities such as login, register, and logout, S3 bucket functionalities, design some user interfaces, and we, we planned to complete partially LSH and KMA component integration. That means generate the tree using LSH and KMA methods and neural network functionalities to update the phylogenetic tree and testing part. Among those things, we have done all the things and we were able to complete generating tree by LSH method. In future, we are planning to do KMA component integration, neural network functionalities, all the things, and we are planning to make a user guide to explain how to use the product.